Xin chào các bạn. Trong video này chúng ta sẽ cùng nghe Chales Hoskinson giải thích về thuật toán đa đồng thuận. Như các bạn đã biết, ngày 8 tháng 2 năm 2022, IOHK Hồng Kông đã mới công bố một bản nghiên cứu về Hybrid Consensus, tức là đồng thuận hỗn hợp. Đó là một báo cáo nghiên cứu về sự kết hợp giữa cơ chế đồng thuận Proof of Work và Proof of Stake. Mặc dù trong quá khứ thì đã có một vài blockchain sử dụng cơ chế hỗn hợp này, tuy nhiên thì đây là lần đầu tiên cơ chế này được thực hiện nghiên cứu khoa học dưới dạng peer review, tức là chứng minh về mặt học thuật trước khi mà triển khai thực tiễn. Trong một Twitter của mình thì Hoskinson có đánh giá đây là một bước tiến lớn để mở đường cho thế hệ blockchain 4.0 ra đời với đa cơ chế đồng thuận, tức là nhiều hơn 2 thuật toán đồng thuận trên một blockchain. VR sau đây đã được Hoskinson thực hiện cách đây hơn 8 tháng sau khi tham dự hội nghị Bitcoin tại Miami. Và chúng ta hãy cùng nghe để hiểu rõ hơn về vấn đề đa đồng thuận. Chúc các bạn thu được nhiều kiến thức bổ ích.
Hi, everyone. This is Chales Hoskinson broadcasting live from warm, sunny Colorado. Always warm, always sunny, sometimes Colorado. My apologies for being a little bit late to the live stream. There were some technical difficulties, and then we had an unexpected visitor to the office and caught me right when I was just about to click broadcast. And I didn't realize that the live stream was already connected to YouTube. I thought I was just in the waiting room to initiate the live stream. So I wasn't actually aware that you guys were waiting so long. So my apologies for that. Anyway, I did want to make a video because on the back of the Miami Bitcoin conference that I attended, I could not believe the level of disinformation, FUD, and mean-spiritedness coming from a lot of maximalists in the Bitcoin community over the things that we do on the proof of stake side of the world. And to this point, I think it's become no longer possible to have a conversation with anyone in that circle. They just simply are part of a religion now. And the point of this video is to discuss a little bit about some basic stuff that seems to be completely lost and missed, and talk a little bit about stuff we're doing in the space as it relates to consensus. So as many of you are aware, the engines of cryptocurrencies, the things that get them to transform from one state to the next state to the next state, is a consensus algorithm. So what happens is you have this big decentralized mesh of nodes and connections, and transactions are occurring all the time, information's flowing all the time. You somehow have to order all of them in a meaningful way. This is a very classical problem in distributed systems, and it's something that's been discussed and thought about for well more than 40 years. So it's a very old problem, and it was not something that magically was discovered and invented by Satoshi. There were papers in the 1960s and 1970s discussing this problem. From the beginning of when computers existed, people started realizing that when computers are in different locations, perceptions of orders of events are very difficult to ascertain without designating a trusted third party to take care of that. So proof of work is just an engine that basically allows you to make decisions of who gets to decide the serialization for that moment, that update of the system, that block. The heartbeat of a blockchain is a block. Every time a block comes, the heart beats, transactions get approved. Proof of work is just a type of engine. So let's talk a little bit about this. And what makes this video exciting is that we actually get to talk a little bit about where the future is going. And I think this is something that's really not discussed very much. Okay, so this right here, if you all can see my nice little blackboard, whether your proof of work, it's kind of a trippy color. Let's go to white because that's a little easier to see. Whether your proof of work or proof of stake, you have the same three things that happen. Okay. One, you have to choose someone in charge to order everything that goes into that heartbeat of the system, the block. Two, you actually have to beat the heart. So you make the block. And three, the network has to accept the block. All right. Proof of stake and proof of work are basically identical in steps 2 or 3, in that you can put a proof of stake system in Bitcoin and Ethereum and other such things you're not going to actually change the ledger rules or the validation predicates or all the kinds of things that would go into accepting whether something is real or legitimate. Where they differ is here. How do you pick somebody in charge? It's done here with, and they both use different notions of resources. Let's use that term, resource. Okay. In the case of proof of work, this is based upon hashes. So how many hashes per second you can do. In case of proof of stake, this is based upon ownership of an asset. All right. So the resources differ, but the concept is basically the same. If you control 25%, let's say, of the total amount of hashes per second, the total amount of hash rate in your proof of work system, on average, 25% of the time, you're going to be selected to be in charge. Now, that's not always the case. You know, you can sometimes 18%, sometimes 35% of the time. But on average, if you graph it out and you go over a long enough period of time, the numbers will cluster around 25% of the time. And it's the same for proof of stake. If you own 25% of the system, well, then on average, 25% of the time, you will be, or the people you designate your proxies, the people you delegate to, will be in charge and have the right to make block. All right. So the point of this video is to say, hang on a second here. This is just a resource. And guess what? You can combine these together. There was a cryptocurrency in 2011 called Peercoin. You guys remember that? Sonny's thing. That was actually a hybrid proof of work, proof of stake protocol, which meant that it actually didn't have one resource, but actually had two resources. So people could mine, and they also, because of their ownership of the network, could also be selected to make a block. And there was some mechanism within Peercoin to work on that. In 2016, there was a follow-up protocol that was made by Hung Chang and Alex Chirpinoy called Twins Coins that actually tried to improve that model. And there's still a lot of thought and work onto how do you go from one resource in this system to decide who's in charge, to two resources, to eventually n resources. Okay, so you have a blockchain. In each of these slots, you're going to make a block. And there's a question mark of, well, who's the person to do that? Because there's an expectation that blocks should be made with some degree of regularity. So in Bitcoin, it's 10 minutes. In Cardano, it's roughly 15 seconds, give or take. Sometimes more, sometimes less. We try to keep synchronized. And each version of Ouroboros has a different opinion on the rate that they come. But anyway, you can say, well, only one resource decides this, or two, or n, many resources decides this. So why would you want to do that? Well, every pool of resources comes with a philosophy behind it. So if you're selecting resources out of the proof of work side, then you are making assumptions about the availability of ASICs. You're making assumptions about energy cost. You're making assumptions about knowledge, domain expertise. It's very easy for a person delegating Cardano. It's a virtual resource. It can move anywhere in the world. It's very hard for people to build a $200 million data center and run that data center. Okay, so there's different expectations you're making about these things. And for proof of stake, you're making the expectation that somebody actually has the ability to buy ADA, that markets exist, and that those markets are relatively decentralized. And there's always a seller for a buyer to basically get some ownership over that virtual resource. You're also making assumptions about the level of veracity, honesty, credibility of the people who control these resources. So with mining, you assume an honest majority. With a plutocratic system like a proof of stake system, you assume honest majority. And the incentives for honesty are different. So in proof of work system, the incentive for honesty is if you wreck the token, then your miners decrease in value if you can only use it on that token. And in the beginning, that was true to a certain extent for ASICs and other such things built for Bitcoin. You could mine other things that were similar, but the profit margins were dramatically smaller. But when you see things that use the same algorithms and the work rate is relatively the same, the price is relatively the same, you actually have perverse incentives to do what's called a Goldfinger attack. In the case of proof of stake, you own the system. So if the price dramatically decreases, you're actually taking value out of your own pocket. Excluding the existence of derivatives and short selling and other things, that seems to be a rational assumption, but it may break in certain cases. So in the effort of resilience, the goal of going from one resource to N resources means that your system is more overall dynamic, because you're getting your security, you're getting your block production from more than one pool potentially. But there's a really difficult question of how do you stitch these things together? And actually, it turns out that the TwinsCoins paper had a few issues with it. And attempts to create hybrid proof of work, proof of stake systems is a little bit more elusive. The other thing is that your resources don't have to be connected to a computer-driven or ownership-driven model. So in many cases, you guys will hear things like proof of merit. Okay. So that's this concept of, and there's many variations of it, et cetera, et cetera. But basically the idea is that somebody does something beneficial, we'll call him Bob, for your cryptocurrency. And the more good things that Bob does for that cryptocurrency, and we'll just put that in quotes because who the hell knows what good things are, he'll get some sort of token for that. And that token represents a resource. So identifying the good things and a fair way of distributing that is actually an ongoing research problem that's really exciting and sexy and cool. And then also, how do you make sure Bob is real versus a bot, robot Bob? Give him little laser eyes. Okay. So that is what's called civil resistant. Okay. So there are other resources you guys could have. Like, for example, let's say that, your blockchain is getting really, really big and really, really heavy. The totality of all this, if you sum up your blockchain, let's zoom in right here. Yeah, here we go. You sum up your blockchain, the sum of this whole thing. And that equals like 8 exabytes. All right. So a huge amount of data is there. Well, who's going to store that? So maybe you can do proof of storage. And there's some really cool protocols, like, for example, Permacoin was one that I'm familiar with. But there are things that have come since that time. Chia is another ecosystem that's trying to figure out ways of connecting history to a blockchain. But, that could be another resource. You could actually, instead of saying hash power, it could be hard drive space. Okay. So the name of the game, once you have a strong theoretical basis, is to say, okay, let's go from 1 to N resources. And then you select that pool of resources to be a composition of computational power, a composition of social power, so socially good things for the system, things like storage. You could even think of network capacity. For example, right now, peer-to-peer and relays in all cryptocurrencies, at least most that I'm aware of, don't incentivize the relay of information in the network, and also ownership. So basically owning the tokens inside the system. You can actually create, and there are other axes that you can go down. These are all candidates for resources that the system can have that allows you then to translate to that point number 1 of who makes block. And really, it's a balancing act. You create your scales. They they kind of have to balance a bit. And you want to make sure that no one part of this puzzle is overrepresented. What you want to have is a situation where basically each constituency has a voice and they keep each other in check. So, for example, if you're anti-plutocratic, so you really, really hate the ownership of the system, the social components can be biased towards the poor of the system. So that means that your ownership, your Pluto, and your social are balanced with each other. So the rich are represented, but then the poor are represented. If you have a lot of computational resources, but you're constrained on storage and network, you could certainly run applications, but then you can't transmit them, and they're all going to be stored off chain. So maybe you have to keep those three things in balance with each other. So it's a really cool problem to study, and it's something that we've been thinking a lot about. And really the first step in solving this problem is going from 1 to 2. That's the really hard problem. And then 2 to n is a lot easier, assuming you have good protocols for each of these categories. So we actually are thinking about a proof of stake, proof of work style system, and we're examining how one would do that in practice. And we'll be publishing a paper later this year specifically on that. But then our goal is to go from 2 to n. And then once we know how to do it for arbitrary things, it's just a question of how do these protocols compose with each other. So there's something called GUC in cryptography, Global Universal Composition, and it's a way of showing that when you add these things, the proofs don't break. The system will stay in balance. And this is going to be a big research agenda for Cardano 2025. Really, Cardano 2020 was about saying, let's build the best proof of stake protocol the world's ever seen. And the capstone there is what we're doing with Omega. Okay, so that's best in class. It's the fastest engine you can get. It's the Ferrari of proof of stake protocols. My preference is Lamborghini of proof of stake protocols. It's very, very nice. But that will only represent one constituency, just like mining only represents one constituency in the ecosystem. And so the goal is that we need eventually to move towards more constituencies. We need to have the people who vote and the people who are, working every day and evangelizing Cardano, and developers and other such people as part of that conversation, having access to those resources. And by the way, those resources can be delegated. Those resources can be fungible or non-fungible, meaning those resources can be standardized, or they can be non-fungible. They could also experience, they can be permanent, or they can be temporary. So, for example, you can introduce the idea of a social coin, but it expires in 30 days. You can introduce the idea of a network token, but it's only usable by a certain group of actors, and maybe it's permanent or something. So you can always mix and match the monetary policies of these different resources inside the system to represent, the intended goal of these types of things. So this is what we've been thinking about for a lot behind the scenes. And after Omega's done, it's going to be the kind of the next generation of that, going 1 to n and building the economic models for these types of things and creating a lot of these proof of X's for each aspect of the system that needs to be incentivized in a certain way. And what's so cool is the community can make some decisions about how to do that. You can leave it as a plutocratic system and just be a peer proof of stake, and it'll run forever this way if you think that that's the best way of doing things. Or you can mix and match and decide how big of a set of n you want to be and what weights are there. Because right now, with a proof of work, proof of stake, the idea is that you would have one proof of work block and one proof of stake block, and then a proof of work block, and then a proof of stake block. That's kind of an equal weighting. But you don't have to do that. You could do proof of stake, proof of stake, proof of stake, proof of work, then proof of stake, proof of stake, proof of stake, proof of work. So you can weight them differently. So these resources can also be weighted differently. So maybe you can overbias computational availability. You could overbias social availability and so forth. And the weighting mechanism is going to be a really fun thing to think about post Omega. But I just wanted to make a video on this particular topic because I think it's a topic that is the least understood amongst maximalists. And what they basically have decided is this entire picture doesn't matter. Any proof of X is a scam outside of one very particular proof of work. Everything else is wrong. And that any innovation along these lines just simply doesn't work. And there's overwhelming evidence against that. There's peer-reviewed publications against that. There's active running systems with $50 billion in value as acting as counterexamples for that. It just simply doesn't matter. And the problem with Nakamoto consensus, the proof of work that Bitcoin uses, is that you have to use gargantuan amounts of assets here. In the case of energy, it's very expensive. And because you spend so much there, you have less to optimize around here. And the more of these things you can do, the faster those things you can do, the more TPS you can have, and the more users your system can have. So if this is super expensive and takes all the air out, you're first going to centralize the network, and the amount of people who can do it and the domain expertise to do it will continue to get more competitive as the price goes up, and the less here matters. And in the proof of stake world, this is like super easy. Nobody really cares about it. And this is where all the focus is. This is where the sharding occurs and all these other things. Now, you can modify other proof of work algorithms to kind of make all these things more holistic. For example, there's a beautiful protocol that Pramod Viswanath wrote called Prism, not to be confused with our identity system. There's a namespace collision there. And actually, he's able to accelerate Bitcoin with Prism as a sharded proof of work system to have a 10,000x faster than Bitcoin with pure proof of work. It's a really cool paper. If you Google Prism proof of work Pramod, it's one of the first results that will come up. So there's tons of innovation that you can do, but then you'd actually have to change the underlying algorithm. And unfortunately, attending the conference in Miami, nobody even wants to talk about that. You can't even talk about NEPA POWs there. It's a cult. I even had someone throw a toilet paper roll at me that said shitcoin on it. So lively crowd, fun crowd. But all things considered, the caravan moves on, the innovation continues, and it's really exciting to see that we're starting to get these third generation protocols to where they need to be. Omega is going to be a major milestone, and I think that we're also going to have another major milestone with F2. That'll be fun. And obviously, Algorand continues to evolve, and between those three efforts alone, I think we're going to basically peak and have the best version of proof of stake you can have for at least the next 5-10 years. And then it's less of a question about optimizing those algorithms for security properties, and it's going to be much more of a question about which resources do we want to have. And the fourth generation protocols are going to be the ones that have N resources, and they have a much more balanced set of control for the system and the evolution of the system. And it's going to be real fun to see what those monetary policies look like. Okay, so I hope this video was helpful for everybody. And again, sorry for the wait. I wasn't aware that that it was sitting in the lobby for a whole hour. And hopefully there's more conversations to be had about this. And as we start publishing papers, especially the hybrid proof of work, proof of stake protocol, that's going to open up the conversation for how do you go from 2 to N. And then it's just a question of building the right proof of X's and weighting, balancing those proof of X's between each other for a more resilient and holistic system. One last thing. In biology, you have this concept of specialization, cell differentiation, heterogeneous systems. So you have nerve tissue and heart tissue and skin tissue, and each one of these tissues do different things. So they all start from the same origin, and the simplest organisms are single cell, but you learn very quickly that if you want to do more and have more complexity and actually be useful, like have eyesight and cognition and live long periods of time and have an immune system to protect you from other organisms, you need to have cell specialization. Cryptocurrencies are no different. Bitcoin was built as a homogeneous system. And we're moving from homo to hetero, meaning that different nodes do different things and different actors. So proof of stake, for example, what makes it work so well is you kind of have your delegation set. So these are people who hold the resource, and then you have your stake pool operators. And the SPOs are physically different. They're usually whole nodes, full nodes, and they run the whole network. They run relays, and they're around 24 hours a day, 7 days a week. They usually have stronger, beefier computers and so forth. And the people down here, they're kind of just, they can just have a cell phone. They can just be a Yoroi user. They can be on an exchange or something like that. But we already see some differentiation between these two. Now, they have the same DNA. They run the same protocol, and technically you could restore the protocol from that DNA, just like your DNA is in a nerve cell and your DNA is in a heart cell and so forth. And you hypothetically could reconstruct the entire organism from that. But what will happen over time is that cryptocurrencies will be built with many different tissue types, and each of those tissues will serve different roles, and the entire system, complex system, will have emergent properties that the single-celled organisms simply will not have. And that's the next generation, is identifying all that different type of financial tissue that can be constructed. And we already kind of see that with the DeFi space, where these DeFi protocols in a way are an extension of the system and a specialization of the system. And they have their own units of account. Uniswap has its own units, and MakerDAO and so forth. And the complex system basically wires all of them together. And so that's where we're going with all of this. And that's really the point of these systems, is we're trying to build an ecosystem that is resilient and capable of dealing with the problems of today and tomorrow, but without centralized control. And if you think about a human organism, a complex biological system, there really isn't a notion of the God cell that runs everything. Your body is decentralized in that respect. You have specialization throughout the whole system, but the system has to be in homeostasis. The different components have to work and connect to each other. And it's not the case that if I remove a single heart cell or a brain cell, then suddenly the system will die. But if I remove too much of any one thing, then the organism dies, because there's an interdependency in the system upon the other connecting tissues. And that's where we're going. And if it's balanced correctly and you have well representation of the resources, then the system will be quite resilient. And that's the end goal. All right. Until next time, everyone. Thank you so much for watching, listening. Had a lot of fun making this video, and I hope you guys had a lot of fun watching it. Cheers.